I got to have forged crankshaft. Okay? Let's talk about forged versus cast. You want to put 23 pounds in your back pocket, go home, and walk around that with the rest of your life. A forged crankshaft weighs 53 pounds. Okay? A cast crankshaft weighs 34, whether it be a 2225. There's that much difference in a forging to a cast. And if I have to propel that engine and accelerate its speed, I want lightness, okay, of all my reciprocating parts. That's why Chrysler went to the lightweight connecting rods versus, would you get more crank whip too? You get a little more crank whip, right? Versus the big beam rods. This is the same rod that was used in the carbureted cars in '81. Okay, they changed it. Now be careful. Let me show you a secret on rods. You know that. There's a couple charlatans around that are selling you guys Turbo 2 connecting rods. And I'm going to show you an easy way to identify a 2.5 connecting rod. I'm sorry, I keep going back to 2.5. A Turbo 2 connecting rod. That is a Turbo 2 connecting rod. Big beam, full floating bushing. Okay? But the 81 through 85 connecting rod looked just like it. And I could make some forgeries. All I got to do, even though it wasn't full floating in here, was bore this out, put a bushing in it. Here's a full set of, Turbo 2 connecting rods for 250 bucks. Okay? But there is a slight difference in them. When we came out with this connecting rod, we added a little bit of strength in the cap down here at 5, okay, and about 7 o'clock, right there. See those little ears right there? On the early rods, that wasn't there. This was just a straight round casting, right there. And there's a hell of a lot of metallurgical differences in this crank, or this rod, okay? From the 81 to the Turbo 2 rod. That rod is heavy. It's a big beam rod. I've never seen one break in two. I've never seen one of the lightweight rods like our GLHS cars were built with Turbo 1 componentry in the motor. They weren't built with Turbo 2 stuff. You ever seen one of those rods break in two?
Can't break them.
You can't break them. But everybody says, I gotta have these guys. I can't get these anymore. Mine for low car performance for 75 bucks a piece, but you got nothing. You got to do a lot of work to them. The worst problem is up here in that bushing. Okay. Magazines force us to do a lot of things. They'll tell you that. That's the toughest thing in the world for these critics to come out. They're halfway mechanically knowledgeable, and they say Chrysler doesn't have a 16-valve motor, and you guys don't have full floating pins on your pistons. You know how much a full floating pin is worth in horsepower? Okay? It has one advantage. You don't have to press it apart with a machine and break the piston. You can take the little spiral locks off, okay? You can take it apart. So it has no advantage.
It does nothing with heat.
Nothing with heat. But we did it the cheapest way we could. And we do this sometimes. And I'm the first one to knock what we do and what Ricky and I do is, from Chrysler. Is they have a steel back bushing that is dipped in brass, and its life is pitifully poor. And if you guys rebuild this connecting rod, the first thing you want to do is knock that bushing out and find somebody that can go back in with a full brass bushing, okay, that can take the loads, and then you drill a 5/32 hole down through here and then counterbore so that you can get oil into that pin area. Okay, one thing you want to do to that connecting rod.
That work with a Turbo 1 rod.
Yes. Pistons. 2.5 versus 2.2. This is a 2.2 Turbo 2. This is a 2.5 Turbo 1, because they never made a 2.5 into a Turbo 2. But same goddamn piston. Everybody says the pistons aren't as good in the Turbo 1 as the Turbo 2. The difference is
One's a full flow and one's not.
Rams. Okay? Want you guys look at something. Look at the weight. Okay? Now I want you to look at old technology versus new technology. See how far the deck height is of that piston to the first ring lamp? Look at that piston. And look at the deck height to the first ring lamp. This piston right here, if everything was exactly the same, even we got differences in stroke now, we got differences in dishes. Don't look at that. Just look in the pure mechanics of the way those two pistons are built. I've got probably 200 thousandths higher ringland on the later model 2.5 piston than I do this piston that was designed several years earlier. So what have I got? There's a man with intelligence. I just raised my thermal efficiency by increasing the compression ratio of that 2.5 piston by raising the ringlet. But you can go too far with it too. He'll tell you that. Boy, you can go up and you can raise that ring all the way up on the top. Make some phenomenal horsepower. But you'll cook it to death. And it don't live at 1600 degrees. Okay. Now, the other shortcoming, both of these are full floaters. Both of them use, even though this 2.5 Turbo 1 uses the big beam connecting rod that we call a Turbo 2 connecting rod, same connecting rod. Okay? But the big bad shortcoming of this piston is manufacturing volume. Take those little clips out of it. What retains this full floating pin. Now what did we say the horsepower advantage was of full floating pins? Why did we do it? Because the magazine said we needed to. And it's nice to put in a magazine, we got a forged crank, we got full floating pins. Sounds good to the guys that don't know. Okay? Maybe the forged crank might be an advantage in the 88 block. Because the block torsionally twisted at 250 horsepower. Might be an advantage as far as some degree of strength. Okay? But in a common block, a cast crank or a forged crank is a detriment because I'm pulling the extra 23 pounds. Okay? The other shortcoming is this full floating pin. Now, what do I mean by full floating? Instead of this pin being seized into the small pin bore of that connecting rod, it rides in that bushing and it floats. And what holds the pin in position now is this little round circlip. Okay? This is one of the best pistons that you can buy besides a Vanola. It's made by Mahle, made in Germany, M-A-H-L-E. They make all of Chrysler's performance pistons. Okay? The bad part of this critter right here, even though Mahle makes it, is you can't buy that piston in an oversize. So if you got a 2.2 engine that you shelled, you're shit out of luck. Chrysler doesn't sell them oversized. They'll sell you E's. What the hell's an E? What the hell's that? In production, we don't have 10,000s, 20,000s, 30,000s oversizes anymore. In production, we know that there's a window of specifications, and we will set down the pure-ass stock bore of this motor is 3.444. That will be an A piston. And we'll stamp the top of this piston A. And the corresponding pan flange on your block underneath the borehole will be stamped A. And sometimes on the back of the block, you'll see it marked B, B, C, D. The hell's that?
On Monday morning.
No, no. You got machining tolerances in anything you do. You got windows. And this is what makes or breaks. Remember that transmission we called a 604? Yeah. You carry holy water with you?
1,000 miles, right?
Right. We built the transmission. When did we launch that thing? 88? 88. I got stuck coming from Detroit to Phoenix in 12 minivans in 87 with that transmission. We lost 2 before we ever got out of Chelsea. We lost 2 in Upper Michigan Peninsula. And we lost the 6th one going across southern Canada. And we had to pack 12 guys into 6 vehicles. We finally lost one in Montana, and it was probably one of the biggest expenses Chrysler's ever had by launching a transmission too prematurely, because it didn't have a wide enough window of production tolerances. Okay? So in other words, when you build things, if you say, hey, the production tolerance could be 1 to 3,000ths, you got a wider track to run around in case you get a little off balance. Okay? But when you only got a production tolerance of 1.8 to 2,000ths, you only got 0.2 of a thousandths that this thing can play in. And boy, if it jumps over that, you got a failure, and I mean a catastrophic failure. You got a problem. Okay? Well, anyway, go back to this piston for just a minute. A's. An A is 3.444. Okay? Every alpha letter is about 1/3 of a thousandths bigger.
Only a third.
Only about 1/3. So it's about 0.3 of a thousandths bigger. Maybe 4, okay? But it allows a window to go to A, B, C, D, and we never go any bigger than D in production. Mopar Performance went to mail and bought up all their E's. And they sell them through the Mopar Performance catalog. Okay? But we never used them in production. Never saw an E piston in production. They bought rejects. That's what they bought. Pure and simple. Rejects.
Sell them for premiums. Great country.
Sure it would if you're trying to keep round cylinder walls. And the hardest problem in a Chrysler 2.2 is keeping them round. Water calling this time of day. Anyway, the problem with the 2.2 piston is that Mahle, even though they entered the OE market, which is original equipment, for some reason they have never released this piston into an oversize. You can go to Chrysler parts counter and buy E's, but you can't buy a 10, a 20, a 30 thousandths over. So if you got a worn out block, you're screwed. Okay? By buying a Mahle, an HLA or Molly, whatever you want to call it. I'm going to get into this in just a minute. Now, let's talk about OE suppliers supplying pistons for just a minute. You ever heard of Silverlight, Federal Mogul, Mellings? They're all made by Federal Mogul, packaged under different names. Ever heard of Hyper-Eutectic? Hyper-Eutectic is nothing more than a set of 2% silicone added to this. It's about 8%. By going to 8% silicone, I have now reduced about 25% of my additional casting and excessive material waste because I can manufacture it in closer tolerances. I got parts now that pop out of the mold and with no defects in them. Instead of flashing, I can make turbochargers with housings that look like this. Okay? Much more intricate housings. Okay? But I've got a piece of piston that's borderline junk because it's filled with impurities, and when you slice one of these things in half, it looks like Swiss cheese because that's the silicon pores that are opening up inside. It casts beautifully on the surface. But who's ever going to cut a piston in half? But us that got performance cars, and this piston was only designed for 10 pounds of boost, that piston might work called a Hyper-Eutectic. The salespeople that try to sell these Hyper-Eutectics say, hey, this is a plus. These pistons going to be run so much tighter. They're so much better. You know, you always got to turn a negative into a positive. But now we've got a company who makes these things, who can pop them all out of the mold. And instead of having a 3% reject rate, now he's got 0.3% reject rate. He saved 25% materials. He's got a whole bunch more pocket money in the manufacturing of that piston. Okay? That's what you got to buy out there. And if you get those Hyper-Eutectic Mellings, whatever the hell they are, Federal Mogul, Silverlights, and you put those in your motor, guess what you're going to have at 14 pounds of boost?
Junk.
That piston cannot handle the thermal loads that a turbo engine exhibits, whether it be 1400 degrees, 1200 degrees, or whatever. You combine pressures and heat, and a cast piston does not have the structural strength that this forged piston has. This forged piston can take probably upwards of 25 pounds of boost. Its construction is totally different. Here, the advantages of forged over cast is phenomenal. And they can cast this piston lighter than they can cast this piston, or they can forge this piston lighter than they can cast this piston. Okay?
Ed, this man's got a question?
Yes.
If you ever want to convince yourself about the difference in pistons, take a cast piston, take a Hyper-Eutectic, and take a forged piston, and your biggest ball-peen hammer, and you will absolutely shatter a cast and a Hyper-Eutectic, and you will just barely dent a forged piston.
you guys go out and buy Silverlights and try to build up a 2.2, boy, you can buy these things for $100 a set. And you're just wasting your money time in and time out. Now, I have diligently tried, talked to Mail in Germany, a good buddy of mine that worked for Chrysler, who eventually quit, who was a German national, went back to Stuttgart, where these things are made, okay? And he's trying to get them to make these things in an oversized for me. You know, I've been fighting it for 2 years. I can't get them. For some reason, the bureaucracy won't make this 2.2 piston available from Mail in an oversize. So we got to go to the aftermarket and buy all that crap. Or you got to buy a $400 set of Vanollas. Okay? Now, by going to a 2.5, one advantage again. For some unknown reason, even though this piston here is the same structural strength as it, what's the difference in these pistons? Skirt for one, but they got to run a shorter skirt on this one because this one's got a whole lot longer stroke, or it'll hit the crank. That's about it. Still, 465 grams, 392 grams, that's a lot of weight. This one's a whole lot lighter. I mean, this one needs all the help it can get because of that rod angularity problem. Okay? But for some unknown reason, Mail has decided to make these pistons available in 10, 20, 30, and 40 in a 2.5. I can get them all day long. $150 a set.
Very similar to Volkswagen.
All day long. Full floaters. They can press fit, whatever the hell you want to do, but you can get these all day long, and probably one of the best quality pistons that you can buy, and not that Silverlight crap that's so susceptible to cracking. Hopefully we'll have that piston available in a year. For 2 years I've been trying to get that piston available in oversized, and I can't get it. So if you guys have got a 2.2 that's down, and it's wore out, it's going to have bigger pistons put in it, well, you're screwed unless you just throw the block away and go get you a 2.5, and there's an advantage now of going to a 2.5. You follow me? I'm not trying to sell you on a 2.5, but the way 99% of you drive, bottom end launch, torque power, you'll blow the doors off that 5.0 Mustang before he can even shift in the third gear, you know, and by then it's over. You know, if you're going to go out there and run professionally on the drag strip, you're not going to want a 2.5 because of the rod angularity problem. I can't correct it anymore because the pin is already up as high as it can get. I can't go no higher. So maybe the most I could do with this thing with a set of super curler rods, I've already got a 5.9 rod anyway, maybe I might be able to go to a 6-inch rod. Maybe might. What the hell have I gained? Nothing. And I still got something, look at it for just a minute. We got a 5, we start out with a 5.9. Maybe now we're at 6 inches, okay? And we're going to divide this by 4.090. Now maybe I might have that. We're still a long way from 1.80. Doesn't pay to go on. But still, this engine with its bottom end torque, mid-range launch, you know, it just plays hell with the 2.2.
5 9/10 inches is what you're talking about?
Yes.
Not 5 all that?
Yeah.
Okay.
The one problem that is also evident with these two pistons, whether it be the 2.2 or the 2.5, is the way the full floating pin is retained. And you start putting some RPMs on one of these things, they're not retained properly with enough side loading. They use this round circlip that just snaps into position, and it allows the pin to move laterally in its bore, and it hammers that little round circlip. And when you got a little round circlip sitting in there, and you got that pin hammering from side to side, it has a strong tendency to dislodge or just totally deform the piston right there if it's got enough miles on it. So some of the failures I have seen of these full floating pistons and pins of the 2.2 and 2.5 is this lateral movement of that pin.
What about those Teflon buttons?
Yeah, you could probably get somebody to make Teflon buttons for it. They might work. You know, they're not bad. The real true arc ring that you use is this little critter right here. That's a spiral lock. Okay, and you spiral those things into a square bore, and you stack another one in on top of them. And if you look at this setup right here, now this one is a press fit. This one here is. Pass that one around. and that's got the spiral locks pushed into the side, and that really retains that pin, and it side loads the pin, so the pin is in there stationary. There is no advantage of having a floating pin other than disassembly. So I don't let the pin float. I just seize it up in there and let it rotate on the connecting rod. Okay. Absolutely no performance advantage. Okay, any questions on the common block? Yes, Rodney?
You mentioned there's two different blocks. There's a common block and then the regular, you know, the regular turbo 1 block. But isn't there one kind of in between the
Yeah,
two?
that's a tall block 2.5.
No. Did you say some of the turbo blocks were cast common block, but they weren't? They didn't
All
have
blocks are casted the same, and some guys come up to me and say, I got a turbo block. Turbo block's supposed to be so much better than an EFI block. All blocks are casted the same. The only difference in them is how much further they go down the assembly line to get an oil drain back tube port drill in the back, okay? Or if it goes down further enough, it's in a light enough engine, it's got cross drilled.
Well, I bought a replacement 90. It was a replacement for an 87.
And you probably got a common block, early design block.
Well,
And that's what's happening out there right now. Chrysler has ceased any more casting operations, and we sold all the 2.2 tooling. And before we sell any, let me tell you how parts go for a minute. And this, again, I've been away from it for 3 years, and things may have changed. If there is no movement on a part number in 12 months, that part gets put on probation. And it gets looked at by parts procurement and supply. And they said there's no movement on that part number, okay? And they may look at it for another 12 months, and if there's no movement, it goes NS1. And you've heard that term before. NS1 means no longer serviced. Okay? We try to forecast in the future what we think might be needed for 10-year supply of parts. And we did that with those IROC heads that all failed. The crack between the sand ports, okay? Yeah, the VN, well, not the VNT turbos was another one that created, you know, but that was a turbo problem itself. Anyway, we try to look far enough in advance to say, okay, we're going to put 10,000 blocks in inventory. Well, anyway, we stopped casting in about 1990 the early style block. Even though that it was the early style, and how can you tell it's an early style block, an 88 down block, it's got a fuel pump block off plate on it, okay? Common blocks were never made with this fuel pump block off because they're all fuel injection. This was made for manual fuel pump. Okay? But in 1990, we stopped using that old weak block design. So if you right now go out and buy, and hopefully it's new stock, cast it since 1993, and you go buy an 86 block, and it was casted in 1990, 9 chances what you're going to get is going to be a common block that looks just like this old style 88 block, but with all the common block features. And what are some of those features? Main caps. The biggest strength on the engine is the change in main caps. An early style block has that main cap. 88 down has that main cap. Nice and round. There is a common block main cap. See the difference?
They won't interface.
You could interchange them, but you're not going to have the bulkhead strength below it. It's like me putting a big pair of boots on you, and you're going to go out and be a
Really small feet.
right for really small feet. There's no advantage in putting overkill when you don't have the webbing down below to handle it. Okay, so you can see the difference right there. Look at it, Christ's sake! You're 200, 300 thousandths taller, and look at the strength around the beam right there. That's big time.
Was that made because of the force strength?
Not necessarily, no.
I mean, higher weight.
It was, for, yeah, some of it was, right, because the difference in snout loading by the 16-valve motor. Because when you add double camshafts, you really create a greater snout loading on the front of the crank. Okay? So this had to, and the increased horsepower requirements, so you don't create that torsional twisting of the block. And when we built 88 down motors that we naturally aspired, I had naturally aspired road race motors that had 285 horsepower. Naturally aspired in IMSA. And that's running 14, almost 15 to 1 compression ratio. Boy, when you're cranking that kind of power out of a naturally aspired motor, you start torsionally twisting. I mean, you really start twisting the block. And you'll start popping off number 3 main cap. It'll just break right in half. And when it breaks in half, everything else goes. You got such massive destruction down there. What came first, the chicken or the egg? You know what you got. That's tough. So there's a lot of advantage of when you guys do a rebuild, of going up, jumping up to an 89 common block, and then making that decision right there. You know, what did I say to me over a 2.2 versus a 2.5? You might be able just to go jump and throw a 2.5 into the car, and hey, it's an easy conversion package. You got yourself a good drivable car now. But it eliminates. Let me tell you some other things that happen. The longer stroke from 3.363 to 4.090, you got more volumetric efficiency of your exhaust. You got more volume coming out to move the turbo. So not only do you have a bunch of increase in displacement from 122 cubic inches to 153 cubic inches, you've got what to think about. Here's another factor for you to think about for just a minute. What goes into the intake and what gets combusted and what comes out the exhaust is only 22 to 24%. What goes in the intake, this is another formula that's magic, just like the 1.8. And what comes out the exhaust in anybody's motor is 22 to 24%. Now, think about math for just a minute. I'll give you something to think about. Are we already a little overkill on exhaust with that formula? And guys are sitting down spending $400 and $500 putting IMSA exhaust valves with Siamese seats against the intake? When we get to the cylinder heads, we're going to talk about that. That's not quite the way to go. Because once you Siamese an exhaust seat to an intake seat, you're transferring heat. And you got 2 totally different materials of the exhaust to the intake, and all that exhaust heat's going to go into the softer intake, distort it, and you lost your seat. So all those big sales advantages by some of the guys that are doing these performance heads and say, I'm going to put IMSA intake and exhaust valves on it for you, I'd hang up on him because he doesn't know anything about meteorology. Don't interlock seats. You don't need a bigger exhaust seat if you go back to my formula. We're already overkill with what we got. What time is it? What time is it? What time do we take a break? Everybody want to take another break? Are you okay started? You want to keep going? Am I boring everybody? No. I'm not boring anybody.
Saying so far, 2.5 common block.
If I owned an 86 Turbo 1 Shelby Charger or whatever, and I was getting, I was getting tired, my little Turbo 1 was getting tired, I would go out and find me an 89 2.5 Turbo 1, and I would put all my Turbo 1 pieces on that, use that 2.5 bottom end, and you got yourself a kick-butt car.
With no balance shaft.
And take the balance shafts off and throw them away.
How about the cranks? Ford versus the gas.
When you're in a common block that's got so much more structural strength on the bottom end, you don't get that torque. Our engines don't go above 6 grand. Any of you guys that are buzzing above 6 grand, you're listening to noise. I'll fly you to Houston and go into the dyno room with me, and we'll take one to 6 grand. And you'll see the power curve comes up like this, and baby, it's just falling off like a rock. You're hearing all that noise down there, and you ain't going nowhere. Your shift points ought to be 5,800 RPM. And even with this prototype camshaft that I've got in this one right here, which is different than a Super 60, okay? Even that one doesn't go above 6. It don't work. The motor don't work above that RPM. And I even run special lifters. Okay. Any questions on common block?
Back to the harmonic dampening.
Yes.
Your explanation makes sense, but it didn't fit the one exception, the Turbo 3. Why did they put the balance shafts in the 333? And I'm understanding correctly by saying I should probably get rid of them and take advantage of the horsepower gain. Is there any disadvantage?
You ever work in manufacturing? Kenny's a manufacturing.